Welcome to the video on linear systems in two variables. So, well, first let me explain. So, two variables, okay, so that means we have two unknowns, and you're watching this hopefully because you've watched all the videos related to graphing a line, okay? So if you're going to take a line in two dimensions, so let's say x and y, as you see there, then you can graph a line by using slopes and intercepts and take those particular lines and then analyze them as you wish. So the last topic in terms of discussion of graphing lines and understanding lines and everything to do with slopes and intercepts and so on is basically the concept of linear systems. So the word linear, at least for the time for us, just simply means lines in two dimensions. So I'm not going to expand on anything in higher dimensions. Okay, so if you take a piece of paper and you try to draw a line, then you can consider that as being linear. Now, a system is basically a concept where you start constructing more than one line. And for the time being, it's basically if you take any two lines, you want to be able to know what happens to those two lines. Do they intersect? Do they not intersect? Okay, so what is happening? So when we say a system, we basically are referring to a set of two lines and then asking ourselves, what is happening with those two particular lines? Now, I hope that you've watched and understand the video with regards to slopes and intercepts and the standard form. So I will put up a link, okay, so to the core video with regards to just graphing lines, and I will assume that you know how to do that. Now, there are two ways that we typically see lines and that I have gone over in those videos. And one of them is the first one, and that's this one right here, where we're just having a line in a regular slope and intercept form. Okay, so where your M is basically your slope and then your B is your y-intercept. And if you look, okay, so I have two lines, so they might possibly have different slopes and different intercepts. Another way of actually describing lines in an equation is with the standard form. So as you can see, so the one just below it, so right here, okay, so this is known as the standard form, okay? So that particular standard form, if you want to learn about it, I will put up a link again, so up above, okay, just if you want to know a refresher. Now, they both represent exactly the same way of expressing a line, but they just look a little bit different in terms of an equation. I definitely enjoy and like this particular description in terms of slopes and intercepts when you're talking about just two variables. Okay, so it's much easier to graph and much easier to pick up the slope and then the intercept. Okay, so you can very quickly get some concepts out of that. So what are we going to do in this video? We're going to basically take the two lines and then ask ourselves, okay, so what can happen when you have two lines? So I've put a few graphs in here and I'm going to show you that basically three things can happen, okay, when you have two lines in two dimensions. And probably the most common one that you run into in school is that you can graph a line. So now it doesn't matter, you know, how the line looks like. So let's say this is one line and let's say here is the other line. And that is, okay, so let's say this would have been line number one and this would have been line number two. So that is your linear system, all right? So those would have been your two lines. And as you can see, okay, they are intersecting in a point. And that's what happens as one of the cases, most common cases that you see throughout school. Okay, so it is the intersection, okay, that you have in just a point. And that you can find whenever you have, so if you graph them visually, you can actually see where the intersection is and then you can kind of pick it off. The only problem is when you are putting this on a graph piece of paper, sometimes the intersection doesn't fall exactly on your grid. and then you're kind of guessing what the point is of intersection. So it's a little bit easier just to do it actually through some mathematical algebra, okay? And I'll show you how to do that. But that's one thing that can happen to a linear system. They can intersect in a point. Now, another thing that can happen that you may run into, you can have a line. So let's say you have one line right here. And so now I'm going to cheat a little bit. So I'm going to take this line and duplicate it, all right? Now, if I duplicate it and I kind of shift it away, so you notice that you have parallel lines. And sometimes for parallel lines, you know, what we will do is, okay, so we put these kind of two lines through it so that we know that kind of they're parallel. Sometimes some people just put one slash through each. Now, what does it mean to be parallel? So we basically mean that they have the same slopes, right? And they never intersect. And, you know, if you really want to learn a little bit more on how to spot those parallel lines, so I'm going to do a little link. Okay, so as I said, so this is a set of videos. Okay, so I'll do that link that you see there, and you can click on that if you want to learn about parallel lines. And for these systems of parallel lines, clearly there is no point of intersection. So there is no intersection at all for these particular two lines. And we can spot that, okay, when they have the same exact slope, but they have, for example, different intercepts. The last thing that can happen with two lines is, it's kind of strange, but you can have two lines, or at least they look like two lines, where you basically have just some line going through, and the other line is actually a line that you would have, and it falls right on top of the other line. So if I would duplicate this, let me just change the color so that you can kind of see. So here, let me change the style, and I'll put this as a red line. And now I'm going to start shifting it. So at present, it would be just a parallel line, right? But as I shift it over, okay, and then eventually I'll just put it on top, and I'm going to just shift it a little bit above so that you can still see the blue there. But these two lines are basically the same line. So they're intersecting at every single point of the line. So the line itself is actually the point of intersection, or meaning points of intersection. So there's infinitely many, because it's a line that you have that goes on forever. So those two particular lines just fall on top of each other. So those are the three things that can happen in these linear systems. They can either intersect in a point, they can never intersect if they're parallel lines, or they're actually going to intersect in a line where they're just falling on top of each other. So I want to just show you a few examples. So here are a few examples of various lines, and we're going to work through them so that you can see how you can actually find, if someone gives you the equations, you can find the point of intersection, all right? If there is a point of intersection, of course. So let's take the first one. So I'm going to take this first example. So I have two lines. Okay, so this is it. Let me copy this down, and I'm going to start bringing them down, and we're going to work through them together. Now, if you're looking at this, both of these lines are in slope-intercept form. All right. Now, if you really want to check, okay, and very quickly know if the two lines are going to intersect in a point or not, all you really have to check is what is happening to the slope, all right? So what is happening to the slope? So the first equation has a slope of 3, and then the second equation has a slope of -1. So we know what the slopes are, and they're actually different. We also know the y-intercepts, and the y-intercepts are different. So because the slopes are different, then we are guaranteeing ourselves that the two lines are going to cross each other at some point. And we want to be able to find that cross intersection. Okay, so keep that in mind. When the slopes are different, okay, you're guaranteed that there's just one point of intersection. And the way that I do this is, whenever they are in this slope-intercept form, all you really have to do is you have to take your first line, and then you will equate it with your second line for y. right? So for instance, in the first line, okay, so my y is equal to 3x plus 5, and it is equal to, okay, my second line, which is negative x plus 4. So I have just simply copied and I have equated y is equal to y, right, from the first equation, okay, and from the second equation. Now, why do I do that? Because if I equate them, what I'm trying to find is actually the point where they're intersecting. Because if they're equal, they're only going to be equal at the point that they intersect. They're not going to be equal anywhere else. So that point of intersection I can now find by simply solving for x. So notice I have x on both sides, and this is kind of a nice question to see if you still remember how to isolate and solve for a variable. So if I solve this, so I'm going to bring this term over to this side. So we're going to have 3x. All right, so this is going to change sign. So plus x in here, so that's this. Now, on the right-hand side, I have my 4, and I'm going to bring the positive 5 over, so that's going to be minus 5. So that changes sign. And now I can collect my like terms. So this is going to be 4x is equal to, and 4 minus 5 is basically minus 1. And now solving, so I can divide by 4 on both sides, and you will find that x is equal to negative 1 over 4. All right. Now, if you did this as a decimal, I don't actually like to keep it as a decimal because sometimes you have a repeating decimal, and I don't want to deal with that, but that's what it would have been as a decimal. So they're going to intersect at x is equal to negative 4. But of course, x is equal to negative 4 is just the x-axis. So we still have to find out where they intersect on the y-axis because we actually want to know what that point is of intersection. So once you find your x, all you have to do now is you have to now substitute it back into the original equation. And you can substitute it either into equation 1 or into equation 2, whatever is more convenient for you. All right. So for instance, what I'm going to do is I'm going to take my x and then I'll substitute it into equation 1, and I'm going to find my y. So y is equal to, so this is 3. I substitute for x, which is negative 1 over 4 plus 5. And this gives me, so negative 3 over 4 plus 5. And I can find what my y is. All right. So that's what that would have been. And I mean, I can just take the calculator out in here. Okay, so let me put it in there. So this is negative 3 all over 4. And it was plus 5. And it's going to give me 4 1/4, right? And of course, you can change it back into decimal, or you can change it back and just keep it as an improper fraction, which is what I like to do in these particular questions. And this, okay, tells me that these two lines are going to intersect at the point of x, okay, which is negative 1 over 4, and y, which is 17 over 4. And you can certainly graph the two lines if you wanted to. So we could have graphed these two lines by using the standard procedures for graphing and those links that I pointed out to you in the beginning. And once you can graph it, you can kind of see. But you would have noticed that it's very difficult to spot this because the point of intersection, it's not a very nice point. It's actually fractions. So that is kind of the first example that you see here and how to solve, okay, for the point of intersection. So in this picture, this is what, okay, we would have been looking for. So it's something like that. Now, obviously, it's not intersecting where it is shown here, okay, but those are the lines that you would have had, all right? So you would have had two lines, and they would have been intersecting in just one point. So that was example 1. But what happens, okay, so here is example number 2. So let me take this one and copy and bring it down. So now what happens when the two lines are not so nicely written out in, for example, the slope and intercept form, right? Like they were in this example. If that happens, Okay, and in this case, this is actually written out in the standard form of a line. Well, what you can do is you can A, convert these two lines into the slope or intercept form. So you can do that. So you can change it back into this form, mx+b, for both of these two lines. And then you can do exactly what we did in the previous example. So here you could isolate these for y and then solve, okay, as we did in the previous example. Another way is that you can take one of the lines, isolate it into the slope-intercept form, and then substitute it back into the other line. Again, that will just simply tell you, all right, so where are these two lines actually intersecting? So let me show you how to do that. So I'm going to take line number 1 and I'm going to isolate it. So this is 2x minus y plus 4 is equal to 0. So I'm going to isolate it for y. And then I'm going to, after isolation, I'm going to plug it in back into the second line to find my x. All right, so where they're actually intersecting. So in order to do that, so I'm going to keep my y on the left-hand side, and I'm going to bring my x. So notice the sign changes, and then the 4, the sign changes again. So that's what I have there. Now I can't have the negative, okay, in here, so I can divide both sides or multiply both sides by -1. And if I do that, okay, my y will be just alone, and then the -2 multiplied or divided by -1 becomes 2x, and then the same thing happens here. So this becomes also positive. And now I have my equation of the line in the slope-intercept form, and I have isolated for y. So now what I'm going to do is, this is my first line, I'm going to substitute it into my second line right there, right? Because I want to see where this line, this particular line, is intersecting this line right there. And in order to do that is, you can just substitute it back in. So let's see what happens. So I have, okay, so in that second line, so now it's going to be 3x plus 2, and notice I'm substituting for y. Now, so my substitution is, so this is 2x plus 4, so that's my substitution. That is coming from, again, so from right there, and then it's going to be -4 is equal to 0. Okay, so that is this. Okay, I am transforming it to right there to see what is actually happening. And now I will solve for x. All right, so let us solve for x. So in order to solve for x, I'm going to bring this 2 inside of the brackets to simplify. So this is going to be 3x plus 4x plus 8 minus 4 is equal to 0. Now I can collect my like terms and then bring the 8 and then the -4. I'm going to bring it over to the other side after collecting. So notice this right here is going to be 7x, and this right here is 8 minus 4, so it's going to be just plus that. Now bringing the 4 over to the other side, again, because I am solving for x, so this is going to be -4. So we have that. And now dividing both sides by 7. So that will cancel that 7 out, and we're going to get -4/7. So this is what we have. And again, that's my x value. And once you have your x value, so once you have this x value, now what you're going to do is you're going to take it and substitute it back into equation 1 or equation 2 to solve for y. So what I like to do is I like to insert it back into what I have isolated for. So notice I'm going to substitute it back in there. So it will give me what the y is. So y is equal to, and it was 2 multiplied by, so -4/7, that's your x, plus 4. that is from this equation right here. I'm substituting it right in there for x. And now I can solve for y. So this would have been negative 8 over 7 plus 4. And once again, so I can just do that directly. So I have negative 8, okay, so over 7, and then plus 4 equals, and that would have been 20 over 7. So y is equal to 20 over 7, and now my point of intersection is negative 4 over 7 and 20 over 7. All right, so these two lines are intersecting again in just one point, and that is the point of intersection. Okay, so this is a method of basically substitution back in and trying to solve for your unknown. So you've seen now two examples on how to actually solve and find your unknown. Let's take a look at another one. So with the examples that I provided, so here is another example. So let me copy this down and let's see what happens here. So hopefully the more examples that you see, you know, the easier that it becomes for you. All right. So what would we do here, right? So this is, it looks like our first line looks like it is in the slope-intercept form. So that's great. And then our second line looks kind of like it's in standard form, but not exactly, because we have the 1 on the right-hand side. So what would we do here, okay, in terms of solving? So you can, again, do a few things, right? I can take my line number 1, so this one, okay, because it's already isolated for y, and I can substitute it back into the second equation, which probably would be one of the easier things to do because it's already isolated. So let's do that, okay, and let's see what happens. So I'm going to have x minus, now again, my y, so I am, okay, so this is going to be my y from the first equation. I'm going to substitute it back in. So I like to put it in brackets, okay, because you have that negative in front there and you're substituting for the whole thing. So let's substitute that in. So that is your y from the first equation, and it is equal to 1. All right. And now let's try to isolate for x. All right, let's try to solve for x. So this negative I'm going to bring inside. I'm going to multiply the brackets through. So I have x. So this is minus 2 over 3x minus 1 over 2 is equal to 1. Okay, so no more brackets. And now we can go ahead and collect. Okay, so notice this. So I have x minus 2 over 3x. So you can do that on your calculator and you will find, or you should be able to do it in your head for this one. So this is just going to be 1 over 3x. That negative a half I'm going to bring over to the other side, so it's going to turn positive. This is what we have there. And now this right here, 1 plus 1 over 2 is really just 1/2. Okay, so this is going to be 1/2, or as a fraction, 3 over 2. So this is just 1 and 1/2, which is equals to 3 over 2. So this is what we have. All right, so I have the 3. So now I can multiply both sides by 3. So if I multiply this side and this side, so this is going to cancel that off. I'm only going to have x left here. And on the right-hand side, I have 9 over 2. Okay, and now I have isolated for x. And once you have your x, now you can go ahead and substitute it back into the equation, so either to equation 1 or to equation 2, to find out what your value of y is. All right, so what is your value of y? So we can take any of them at all. So for instance, if I take this, so it's going to be y is equal to 2 over 3. My x is 9 over 2, so this is 9 over 2 plus a half. All right, so that's what that is. And now we can go ahead. Yeah, it's annoying because we have all these different fractions. Okay, so I noticed that here, so the 2 and the 2 cancels because 2 divided by 2 is 1. And I also noticed that 3 goes into 9 3 times. So this is actually going to be 3 plus 1/2, which is just 3.5. Or if you wanted to do it as a fraction, it would be 7 over 2. So your overall answer, okay, your line, okay, and point of intersection is 9 over 2 and 7 over 2. That's what your point of intersection would be. And that's example number 3. So now we have done 3 examples in terms of trying to solve these. And all of these examples pointed out to us that we have just one point of intersection. So we have always been dealing with the first case, which is this one. The last example actually is going to be a little different. Okay, so I want to show you what happens, you know, when it's not just a point. What happens if maybe they're parallel lines of some kind. So these, you can actually spot them much faster, and it's not as much work as the previous examples that we have. So let's try this, okay, and let's see what actually happens here. So it looks like we kind of have 2 equations. They look like they're in standard form. They're not in y-intercept form. So, you know, we can kind of check, all right, so what do we do, okay, in these instances? So you approach it the same way. You're going to pick one line and then try to isolate that line. So I've always picked line number 1, so maybe let's try to pick line number 2 this time around. And what I'm going to do is I'm going to put it in y-intercept form. All right, so I'm going to do this line and put it in y-intercept form. So if I do that, so I have negative 6y is equal to my 8x, I'm going to bring over to the other side. So it's going to be negative 8x plus 1. Now dividing both sides by negative 6. So I'm going to divide it by negative 6 because I want to have just y on its own. And that's going to give me, so let me do that in here, plus 1. Okay, and I've divided this entire thing by negative 6. So we have that. Now this negative 6, okay, so what you have is you have this and that. Okay, so that's going to give me, so let's do that on the side, negative 8 over negative 6. So the negative and negative cancels, and you can see that this is just 4 over 3 because we can divide by 2, we can reduce that fraction. So that's going to be 4 over 3x. And now, okay, the negative 6 and the 1 is going to leave you with negative 1 over 6. All right, and again, the reason is because you have plus 1 over negative 6, which is negative 1 over 6. So that is my equation, okay, of a line. All right, so this is what we have here. And now we can take the second line, so I can take this and substitute it back into my first line. Right? So I can substitute it back into that first line and then see what will happen. All right, so I can do that. Or I can take my first line and I can do exactly the same thing. I can put it in the slope y-intercept form then to see, okay, what will happen. So let's do that. Let's actually put it in the slope y-intercept form for the first line as well. So that will be, so it is 4x minus 3y is equal to, this is negative, so it is negative 3. So let's do that, is equal to 0. All right. And now let's isolate for y. Okay, so if I isolate for y, I'm going to get negative 3y is equal to negative 4x. And we're going to bring the 3 over on the other side as well. All right, so we've brought this over and this over. And that's what you have so far. Now divide both sides by negative 3. So that's going to leave us just y is equal to, and it's going to be 4 over 3x, because the negative and negative cancels. And then if you're dividing by negative 3, so notice what you have is plus 3 divided by negative 3, so that's negative 1. And look what happens here. So we have exactly the same slope. And when you have the same slope, but you have different y-intercepts, then there is nothing really to solve, because this is the case that you have run into. Notice the same slopes, but different y-intercepts. So there is actually no intersection for this line. There is no intersection at all. So if I scroll down here, so this has no intersection. All right, and that would finish that. Now for yourself, I would want you to, instead of, notice that what we did was we put both of them in the slope-intercept form. What if instead you would have taken your line, so this one that we first had, and you would have substituted it back into the equation, okay, for your other line. So something special would have happened. All right, so something special would have happened. So what I would want you to do is try it and then see what happens, and then you can put a comment below, okay, on what you actually notice, and that will tell you, okay, that what you have is you're going to run into something very, very interesting. All right, so for that, you're going to run into, if you substitute that equation, so this equation, back into the other line, you're going to get something like this. 0x equals to something. And so for those who know how to solve for equations, you know that this has no solution. And indeed, because there is no intersection of the lines. So I would want you to put a comment if that's what you notice. All right, so thank you for watching this video. This concept of working with linear systems in just 2 equations is kind of the starting point of a lot of algebra for anyone who's going to go on. You can actually do this for 3 equations and even more, but it does become a headache, okay? With 2 equations, it's much easier to see. Okay, so thank you for watching. We'll see you in a future video. The next video is actually going to be a test that I'm going to try to do on everything to do with these lines. All right, okay, to test you out. All right, cheers everybody. Okay, bye.